This is MOS structure. Each part of the structure is metal oxide, also known as gate dielectric or gate insulator, and the semiconductor, which also known as the body. We control this structure with the bias at the edge of the structure, and this one is the circumstance with the positive bias at the edge of the gate part. In this case, because of the bias, the band bended a lot over here, which is the junction between the gate dielectric and body. And in this structure, which seems like a well, the mobile carriers accumulated over here. We call this circumstance as strong inversion, and we call this group of the mobile carrier as the channel. So this is MOSFET. The full name of it is metal oxide semiconductor field effect transistor. So we mean that this structure is made of MOS structure, and it is used as a transistor which work with the generated field effect. Yeah. So anyway, in this case, if we make a huge positive bias at the gate parts, it makes a same situation with this one. So the channel will be generated at the junction between the gate dielectric and body. So this channel will be linked the drain and source. So with this linked structure, it can make a current flow between the drain and source. If the channel between the source and drain generated, device will operate. So we control this device made of the MOSFET structure by making the channel or get rid of the channel. But nowadays, the device is getting smaller. The channel gets shorter too. That's a big deal because we should control the existence of the channel with the vertical electric field made by the gate bias. But because of the length between the source and drain getting shorter, the bias between the source and drain makes its own channel, even if there's no bias made at the part of the gate part. We call it short channel effect. There are many kinds of short channel effects, like punch through or Giddle, Dibble, and like VT roll off or etc. Anyway, these kinds of short channel effects are made by the strong lateral electric field between source and drain. So we should make less, reduce the the electric field between the source and drain. So to overcome those issues, we make some new solutions these days. One of that is the pocket implant. So make the implant at the edge of the source and drain to reduce the depletion region between the source and drain. It has a effect which reduces the depletion region, and make a barrier just underneath the source and drain to make, also, to reduce the depletion region's area, or the LDD, which is the low doped drain. So insert the low doped drain part at the drain, and also same as the LDD, insert the low doped source at the source part. It makes the lateral electric field reduced. One of the most recent solution of it is FinFET. Make the gate part three-dimensional to make the gate affected a lot by the vertical electric field.